All right, so section 8.2, again, integration by parts. Now, normally you guys have been doing integration by using U substitution, but we're gonna kind of cover things like this. Like, how would you integrate something like x ln of x dx? Or maybe integrating x e to the x dx, okay? Or maybe something like integral of e to the x sine of x dx. All right, so you can't do a u substitution for these. You can do partially u substitution. That's what we call it by parts, because we're going to be able to do a specific method to do this. But it's like doing a u substitution forward and backwards, okay? It is called integration by parts, and I'll show that to you guys right now. There's a definition. So this is theorem 8.1. And it's integration by parts. All right, so this is what this theorem says. It says if u and v, now these are functions, okay, and I think I'm going to state that right now, are functions of x and have continuous derivatives then if you're integrating a function that's u dv, then your answer is u times v minus the integral of v du. Now, of course, that usually doesn't make a lot of sense at first, okay? But here's the deal. They're saying, look, you have one function called u and another function called v. Okay, you have two different functions. And what's going to happen is you're going to integrate one function while you take a derivative of another one. Okay? Now, it's kind of hard to understand it the way they wrote it, so just so that you know, there is a better way for us to kind of map this out. We do it like this. Okay? And what we do is we end up choosing a function to be represented by u and a function to be represented by dv. And the way we do the steps is that we multiply this. Okay, notice how the definition says u times v, right? So you multiply diagonally. And then you subtract by the integral of this product. Okay, so subtract by the integral of the product of v du, whatever that happens to be. So let me show you how this works. Here's example number 1. We are going to integrate x times e to the x dx. Now you get to choose what your u function is going to be and what your dv function is going to be. Now, one of the ways that you can decide which way is going to work best for you is by asking yourself what would be easiest to integrate. Or another question you can ask yourself is, what don't I know how to integrate? Because whatever I don't know how to integrate, I don't want to put it on dv. Okay, dv, let me write this over here. This gets integrated. Okay, that part gets integrated. So whatever you choose for dv, you're going to have to integrate it. So if you don't know how to integrate something on that problem, then you want to leave it out. Maybe you want to use it so that you can do a derivative. So the u portion over here, this is a derivative. You're going to take a derivative of it, okay? So notice how u becomes du, right? You take a derivative, whereas dv becomes v because you're going to integrate, all right? So according to what I see here, I think about those two things, and then another thing I think about is, okay, I have some pieces here. I have an x, an e to the x, and the dx. Now the dx is going to have to go over here no matter what, because in order for you to integrate, you need to have a dx or something, right? dv, dx, dt, whatever it happens to be. So I'm not worried about the dx part. I'm just thinking about x and e to the x. And I'm going to ask myself, is there a function that I can take a derivative of that makes it disappear? So which one can I take a derivative of that will make it disappear? Is it x or e to the x? Anybody know? Taking a derivative of either x or e to the x? Yeah, so it's going to be x, right? So I just realized it's going to seem really funny for anybody who watches the video because I'm seeing your comment on the chat thing, so I'm saying yes, that's correct, and people watching the video are going to be like, who is he listening to? Anyway, so here we go. U dv du and v. I'm going to let u equal to x. I'm going to let dv equal to e to the x dx. Now notice the integral of e to the x is easy, right? That's just e to the x. Now I know it's e to the x plus c, but don't put the plus c, okay? Because we're still not done integrating, so we don't have to put the plus c there. The derivative of u is just dx. So my result so far is this u times v. So let me write this down. Okay, this is equal to u times v, so x e to the x. And then remember, you're supposed to subtract the integral of their product, right? The integral of their product. So it's x e to the x minus the integral of e to the x times dx. Well, the integral of e to the x dx is just e to the x plus c. So now I can put the plus c part, and that's my answer for this problem. Okay, it's x times e to the x minus e to the x plus c. How's that looking for you guys? Are you guys okay with it? My little nod extension, it didn't turn on, so if you're putting that thumbs up, I'm not going to see it. But are we okay? You guys okay? All right. So there's one of them. So let's change this question around just a little bit. We're going to do example number 2. And we're going to do x squared ln of x dx. Now, I forgot to mention this to you guys, but do you notice how in here it's kind of like a product rule, right? Normally we would never get that when we were doing integration. Like it was just one thing, right? But now it's like, oh, it's this times that dx. So some people say, oh, that's the product rule for integration. No, there is no product rule for integration. That's why we have to think of a trick to integrate. Okay, this whole chapter is all about tricks as to how to integrate stuff. So, all right, here we go. So u, du, dv, and v. So remember, the first question I ask myself is there something there that I do not know how to integrate? So what of those two pieces, x squared and ln of x, which one don't I know how to integrate? Kind of waiting to see if anybody can give me a guess as to which one do you think you don't know. And if you're wondering, well, I don't know what two he's talking about. I'm talking about x squared or ln of x. Which one don't I know how to integrate? In other words, if I told you integrate this, you'd say, I have no idea how. Yeah, ln of x, right? So ln of x, I do not know how to integrate. So it would be crazy for me to write this over here because I don't know how to do that. Okay? So let me put it over here. And on the other side, I'll put the x squared dx. Okay? Now I know how to integrate x squared. That's x cubed over 3. Okay? And I know I'm supposed to put a plus c, but like I told you, just leave it out. And then on the left side, the u, the derivative of ln of x, is 1 over x dx. Okay, remember that's called a differential. Whenever you take a derivative like that, if it's not du dx, then it's because the dx must be on the right side. Okay, so that's why we get 1 over x dx. So remember, we're going to multiply this way. Then we're going to subtract the integral of this product. So here we go. The multiplication results in x cubed over 3 ln of x minus the integral of the product of these two things. That'd be 1 over x times x cubed over 3 dx. Now simplified. Normally I don't like writing that second step like that because I'm actually wasting time. You could have simplified that in your head, but let's just show the step. Okay? Later on, hopefully you guys will just leave it out. So this is minus 1/3 integral x squared dx, because x cubed divided by x becomes x squared. All I have to do now is just integrate that x squared, which should be easy to do, and then I'm done. So I get x cubed over 3 ln of x minus 1/3 of x cubed over 3 plus c, which comes out to x cubed over 3 ln of x minus x cubed over 9 plus c. And that's the integral for this problem. Any questions on this one? You guys are okay? All right, so example 3. Now, for example 3, we're going to use a trig function, okay? So example number 3, we're going to integrate x squared sine of x dx. So usually I'll have somebody tell me, like, how do I know when I'm supposed to do by parts? If it looks like it might be what some would call a quotient rule or a product rule inside of an integral, that's usually when you start thinking about trigs. Okay, so maybe it's integration by parts, maybe it's partial fractions, which we'll learn later, maybe it's trig integration or tricks with trig. There's like 4 main ways to do it. So you kind of have to go through those steps and figure out which one works best. But for now, everything's going to be by parts, at least in this section. All right, can anybody tell me what you think you should take a derivative of and what you think you should take an integral of? Like, just think about it. I will tell you this, guys. You're trying to make the power smaller. Okay, you're not trying to make the problem more complicated. Sometimes it helps to make the problems like the powers bigger, like the one that we just did right here. Okay, notice I made an x squared into an x cubed, but I was kind of forced to do it because I didn't want to integrate natural log of x, right? So I wanted to take a derivative of it. So that's why I had to make a power go up. But whenever you have a chance, try to make your powers go down, okay? So in our case right here, what should I take a derivative of, x squared or sine of x? Remember, you can think, do I know how to integrate either one? Yes, I do. So the integration part, we kind of know we can do it either way. But yeah, Alex, I see your answer right there. I would go with that one too. I would say go with x squared because the derivative of x squared is 2x dx, right? It's making the power go down, which usually means that it's trying to simplify the problem. And then for dv over here, I'm going to plug in sine of x dx. Now the integral of sine of x is negative cosine of x, plus c of course, but like I said, we're going to kind of leave it alone for now. So let's go ahead and multiply across, right? And then subtract by the integral of their product. So this becomes negative x squared cosine of x minus the integral of 2x times negative cosine of x dx. Now again, I didn't simplify it as I did the problem, or else I would have taken out the 2 and made it a positive. So let's do that right now. Negative x squared cosine x plus 2, integral of x cosine of x dx. Now you might notice that my integral doesn't look easy like the other ones did. This still looks like a product rule. So since it still looks like a product rule, I'm going to have to do another another integration by parts. Okay? Now, normally, whenever you do a secondary integration by parts, you don't use u, du, dv, and v again because you've already assigned those. Now, if you happen to do it again, I'm not going to get mad at you guys, but it's not good practice, okay? You should probably use something more like a w and say like a dz, okay? Change your variables, because if you use u for both of them, then someone who's grading it is going to be like, hey, how can u be x squared and w is going to be, sorry, and u is going to be something else as well. So you have u assigned to do two different things. How is that possible? So they can kind of get on you for that. So usually it's good to change the letters if you have to do a secondary integration by parts. So remember, we're integrating by parts only for this part right here, okay? Just for that part. So if I had to choose which one I'm going to take a derivative of or an integral of, I think, okay, I can derive or integrate either one of those, x or cosine of x. So then I think, okay, if I had to choose one to take a derivative for, which one would I do? Well, the derivative would be best for x, because then I make it disappear. So I'm going to let x become my derivative. That just becomes 1 dx. And for my integral, I'm going to use cosine of x dx. Okay, and the integral of cosine of x dx is just sine of x. Okay, now I'm going to multiply and then subtract the integral of the product. So here's how you write this next part. Negative x squared cosine x plus 2. And then I'm going to put a bracket there because the bracket's going to basically tell me like, okay, here's the new integration by parts. Now let me see, would you get the same answer if you switched to what you integrated? Eventually you would, Daniel, but sometimes you make your life a lot more difficult. But eventually you will then get the answer that you're supposed to. In some cases, it's almost impossible to do the work if you choose the wrong things. But sometimes if you're able to kind of work your way back, it will give you the same answer. That's why you have to think about, like, what should I choose first? What should I choose second? What am I going to take a derivative of? What am I going to integrate? Like, really think about that, because you're trying to make the problem smaller, which is one of the reasons why I say try to take a derivative of something that might disappear, or something like an x cubed, make it an x squared, right? Little by little, try to make them go away. But it's not always the case. You saw example 2, I got an x squared, I made it into an x cubed. And why? Because I was kind of forced to, because the natural log, I didn't want to integrate it, right? So, all right, so here we go. The multiplication is x sine of x, that's x times sine of x, minus the integral of sine of x dx. Now notice, this is actually good because I know how to do the integral of sine of x dx. So let me distribute and finish up this problem. Negative x squared cosine of x plus 2x sine of x minus 2 integral sine of x dx. So the very last thing, again, you guys should be able to do that, no problem. You don't need a u substitution. You don't need by parts. Just integrate sine of x. And the integral of sine of x is cosine of x. So let's write that out. Negative x squared cosine of x plus 2x sine of x minus 2 cosine of x plus c. Okay, it's problems like this when I would give you a quiz in class and people came out with solutions only, I would give no credit. Because, I mean, if you could do all this in your head, then you should be teaching the class. Okay? So yeah, a lot of times I'd give no credit to some of my students in BC because they would magically just get answers. And of course, maybe they are that bright, but usually it wasn't the kids who were getting the best grades that would just give you answers. And then you're like, okay, let me talk to them because I think something's up. You have any questions on this one? You guys are good? All right, so let's see if I can do this last one for us here. Maybe I'll be able to finish in time and give you guys some time for homework. Okay, in the beginning, you put the integral of sine of x equals cosine. Oh, I forgot to put the plus sign, didn't I? Yeah, it should have been a plus. I'm sorry. Right here, guys, let me change it. I see what you're saying. Yeah, I forgot to put it right here. That should be a plus. Plus 2 cosine x plus c. Yeah, because Alex, that is the correct integral. Integral of sine of x is negative cosine of x. I didn't put that on the very last step. I left it minus, so it should have been a plus. So thank you for that. So example number 4. Integrate x e to the x over x plus 1 squared dx. Now notice this one has 3 functions in it, okay? It has an x, an e to the x, and then a 1 over x plus 1 squared, okay? 1 over x plus 1 quantity squared. So there are 3 functions here. And then add in the differential dx, then we can kind of say there's 4, okay? So the way we do this is you have to choose a pair to take a derivative of and one thing to integrate, okay? So you kind of are at the mercy of this problem. Like, should you take a derivative of x times e to the x dx? Should you take a derivative of x over x plus 1 quantity squared? Should you take a derivative of e to the x over x plus 1 quantity squared? What would be the best thing to do? Okay, so over the years, and you guys will kind of see this eventually, you start realizing that usually the numerator, okay, not always, gets a derivative for it. Okay, and then the denominator portion, the fraction, 1 over x plus 1 squared dx, is what you're going to integrate. Okay, now the u function, x e to the x, that's going to be a product rule. So the derivative of x is 1, so it's just e to the x, plus x times the derivative of e to the x is just e to the x dx. Okay, so there's my du. Now on the left side, I'm going to do a little bit of scratch work. I'm going to integrate 1 over x plus 1 squared dx. And I'm going to do a u substitution. I'm going to let a equal to x plus 1. So dA is basically dx. So this is the integral of 1 over a squared dA, right? Or a to the negative 2 dA. Now if I integrate a to the negative 2, that becomes negative a to the negative 1. Right? Because I add 1 to the power, so it becomes negative 1. Then I divide it by a negative 1. So, of course, plus c, but I'm not going to worry about that. So, if I put the a value back in, this is negative x plus 1 to the negative 1, which comes out to be negative 1 over x plus 1. So that's my integral. 1 over x plus 1, but negative. So notice within this integration by parts problem, I had to do u substitution, right? Integration by u substitution. Notice I did change my variables. Instead of let u equal to, I let a equal to, because u was already being used. Okay. Now, if you want to use u over and over again, that's fine. But when you get to that AP test, you guys better not do that. Okay? Because they will probably mark you off for that. That's bad syntax. So let's go ahead and multiply u times v, and then integrate this product. All right, I think we'll be able to finish in time. We'll see. If we do, I'll put an assignment up for you guys, okay? So let's see. The product is negative x e to the x over x plus 1 minus, okay? Now, v du, it's already negative, so plus the integral of e to the x plus x e to the x over x plus 1. Now, a lot of people say like, oh, great, look, you made it worse. Usually when it looks worse, that means you did something wrong. But I can actually factor the top part. And once I factor it, I don't know if you guys see it, but I can cancel. So all I have to do is integrate e to the x. And that's easy. That's just e to the x plus c. So I'm done. Negative x e to the x over x plus 1 plus e to the x plus c. All right. So I will give you guys your homework for this. I don't have it ready quite yet. Actually, I think I do, but I want to double check. I think it's page 542, 5 through 22. I'm sorry, page 533, 1 through 6, 11 through 22. But I want to double check it, okay? So look for it on your Google Stream. That is the bell. And what we'll do is not tomorrow, over the weekend, work on it. On Monday, we'll see if we take questions, okay? All right, guys. Have a good rest of the day. Have a good weekend.